Hello, everyone. Thank you for staying for the last session of the day. My name is Joel, and I do product at Gelato. At Gelato, we are on a mission of solving the biggest challenge of the Web3 industry, scaling blockchains, particularly for enterprises. At Gelato, we are builders at heart, and we like everybody to get access to the technology. We want to make blockchain and crypto accessible, abundant, cheap, and reliable, so we can all build on top of it. Today, for the first time, we are going to pull off the curtain, and we are going to show all the secrets on how do we run the Gelato platform in Google Cloud. We are going to show you how we are scaling blockchains and how we are running chains for Fortune 500 companies. But before, I would like to start with a quick introduction. I promise you I'm going to keep it high level. I'm not going to go into the technical details, but I want to walk you on how did we arrive here, right? How everything started, what is the problem, why Gelato is solving it, and then Alessio will jump into the stage and show you how we are doing it on Google Cloud. So everything began 15 years ago with the invention of Bitcoin. Bitcoin was the first decentralized, permissionless, distributed ledger. Bitcoin was the first decentralized digital currency, at least at that scale. You can think of thousands of computers all working together to process, transact, and validate transactions. Now, Ethereum took the concept of blockchain a step further. They introduced the idea or concept of smart contracts. The smart contracts are a small piece of application that you can deploy and run on this decentralized network. And when people realized how powerful Ethereum was, because basically suddenly you had the world computer, the most powerful computer in the world, secure, open source, everyone wanted to start to build on top of Ethereum. Everybody wanted to have a piece of Ethereum. But here's where we encountered the first problem. Ethereum was not ready to handle the demand. Just for reference, Ethereum today can handle only 15 transactions per second. That's 15 transactions per second. While Visa, for example, can process 1,700 transactions per second. Now, Visa is just a payment rail. Ethereum is the world computer. It's for games, social networks, digital collectibles, and many other applications. So we ended up in this situation with the best distributed, powerful computer in the world, but it doesn't scale, right? At some point, if you want to transact, a transaction could cost $100 because the network gets congested. Now, if you are a fund and you are moving billions of funds, that's totally fine to pay $200 to use the most secure computer in the world. But if you're a user like me and you just want to buy a ticket, then $200 is not scalable. The good thing about Ethereum is that Ethereum is open source. So people started to propose solutions. How can we scale Ethereum? How can we make it accessible for everybody? And that's when, a few years ago, Vitalik, co-founder of Ethereum, came with the concept of rollups. Rollups are sidechains. Rollups use the same technology of Ethereum, the same components, but with the difference that they run on the cloud. Rollups run on Gelato Cloud, rollups run on Google Cloud. Now, the big benefit of rollups are that they will batch thousands of transactions, compress them into a single transaction, and send this transaction to Ethereum. Meaning that as a user, I can benefit for the technology, I can transact for a portion of a cent, and I still get the security from the most secure distributed computer in the world. Because at the end of the day, my transaction will go and be stored on Ethereum. Now, as every great technology, rollups got product market fit quite fast. And as you can see today, more than 50 billion of assets are already bridged to rollups. There are hundreds of these rollups today connected to Ethereum when users are bridging funds back and forth. Today you can also connect these rollups, and the magic of the rollups is that they're super highly customizable. So we can tailor to our needs. They're extremely cheap to use and extremely cheap to run for the user as well. Now you might be wondering how difficult it is to run a rollup. Well, Alessio will show you later, but running a rollup is extremely complex. There are many pieces, many moving parts. You need to keep it up to date because, yes, we are safeguarding millions or billions of funds. And I like to draw a parallelism like back in the days, Web 2.0, we have a small room in the office, a few people there taking care that our application was running all the time, changing this, keeping the service up to date. Well, we saw how Google Cloud solved that problem, right? Nobody want to do the job anymore, and that's when Gelato introduced what we call the verifiable cloud. This consists of 3 different layers. The first layer is our rollup as a service platform, and everybody now here can go to gelato.network, create an account, and with 2 or 3 clicks, you can launch your own chain, enterprise grade, ready to handle millions or billions of funds in 30 minutes for $99 per month. That's how far we are on how easy we make it for builders to launch their own chain. The second layer is something that only Gelato can offer in the market, and that's what makes us the best and the most advanced platform in the world. These are our native modules. These are all modules and services that you may need in your chain, like price feeds, verifier randomness, smart contract automations, or relay, right? Let's say that you want to have a chain and you want to sponsor the transaction fees for your users because users want to have a chain that is free to transact. Then you can get that out of the box with 1 click when you create your chain. And the third layer is a third-party integration marketplace with all the best providers from the industry, and those are apps you might want to add to your chain. This is a quick video of how easy it is to create your chain today. You can define your own name. You can define your own custom gas token, your own chain. You can select different configurations and modules. And you just need to click, deploy, and your chain will be ready in 20 minutes. At Gelato today, we are running more than 50 chains, processing millions of transactions, and we are releasing a handful of chains every single week. This is a technology that is only growing. At Gelato, we work with the top projects of the Web3 ecosystem, but as well with a few of the best Fortune 500 companies on the world. One of my favorite projects is Fox. Fox partnered with Gelato to launch their own chain called Verify. And what I really like about this, because this chain called Verify is not about a financial application, but Fox had a very particular need. They wanted to fight misinformation. They wanted to fight fake news. So they come up with the idea of having a chain where publishers, not only Fox, could hash cryptographically content and push it to this chain. So then everybody with an extension can verify if that piece of content was tempered or modified. This is fascinating. Fox already on board their Times and many other publishers, and we are seeing massive adoption. What I really like about this is this was impossible before. Can you imagine paying $100 to hash a piece of content and push it to Ethereum? Nobody will ever do it. But rollups now are enabling us to do and solve problems that were impossible before. So if you have a problem at your company, or you have an idea or thinking on how can rollups help you to solve some problems, please feel free to reach out. I'm going to be here around for the next hours. I'm quite tall, and I'm easy to find. Now, please, let's welcome Alessio to the stage, and he will show how we use Google Cloud to host this platform.
Thank you, Joel. Hi, everyone. I'm Alessio, Head of Infrastructure and Operations at Gelato. And this is how complex a rollup is. As you may know, there are many stacks available. So for naming a few of them, we have Arbitrum Orbit, we have zkVM from Polygon. What you see here is OP Stack from Optimism. You see here, do not deploy this at home, at production. This is just an overview, and I will explore with you a bit more about this. So what we have here, we have a few components. Those are microservices that are deployed on a cluster. They have different roles, so they communicate between each other. Internal traffic and external traffic, and we have, of course, a state. As you can see, there are persistent volumes, and what you see on the left side is the sequencer node, so permission node. On the right side is a user-facing node, so read node that everyone could potentially run to scale the chain. Of course, we have L1 RPCs, and also there, if you are hosting your own L1 RPC, that we recommend is, of course, a fractal, so there will be its own complexity inside this. Of course, not like a roll-up, because here you are solely responsible of the security of the chain. So if your nodes are down, probably the entire chain will be down, at least in writing terms. What components do we have here? We have load balancers, we have Cloud Armor protecting the whole, and backed by multi-cluster gateway, this technology from Google that allows us to move fastly and easily between regions, between continents, between different clusters. Right, so what you see here is actually one chain. So if we have 50 chains, this is replicated 50 times. Right, so how we came with all of this? We had to come with automation. We had to come with a fast way to scale, to deploy, one-click deploy, what you saw in the demo video. Challenges. As you heard before, we have scalability challenges, right? So these chains, each of them is its own beast, can have different traffic, and they have to scale in a different manner, both horizontally, vertically, and so on. So you have the usual things to solve that usually Kubernetes is there for that. That's why we opted for Kubernetes and not virtual machines. So of course we could save some money having a bare metal, but our engineering time is much more worth than a single cluster. So we prefer to spend a bit more, but have everything scalable with Kubernetes engine. Security. We manage real funds. We manage real money. So we have private keys. This is, of course, on top of traditional infrastructure, right? So there are other level of complexity that we manage that we will see a bit more in detail later. And of course, stack upgrades. What if we are running a stack and there is a security vulnerability discovered? We need to patch it as soon as possible. Imagining having 50, 100, 1,000 chains, you need to roll out this as a mainstream. Flexibility. What does it mean? We support today 3 stacks. What if a 4th or 5th is coming? We want to be flexible and onboard the next stack as soon as possible to make sure it's fully automated and can be deployed in no time like any other stack. And observability. Once again, imagine many hundreds, probably 1,000 components running. How do you make sure they are up? How do you make sure they are consistent? So observability stack is something we spend lots of time, lots of resources to build. And finally, automation. All of this is not single man, not single team job. We have to automate every single thing. So I can guarantee 100% all of this is automated at all layers. We can deploy a new chain between 15 and 30 minutes, as Joel said. Now, this is pretty much how the infrastructure looks like, really an overview, but this is the journey. We have a user input. Someone wanted a roll-up, register on our website, we record the request, and we have our automation layer. This layer is composed of many tools. Few of them you can see here. I can name Octopus Deploy, a CD tool, HashiCorp Vault, Terraform, and GitHub Actions. This automation layer is responsible pretty much for everything. So from generating keys in a safe manner, storing them, funding them, and of course, publishing, submitting L1 contracts, and generating L2 configuration. On the right side, we have the infrastructure. Each of these, apart the clusters, are per customer. So our Terraform is already configured to deploy all the components you see here, cloud load balancing, DNS, Cloud Armor, and so on. what's really important to understand is also that cloud storage is used together with snapshots to provide the latest state of our chain in order to be shared with third parties or just for fast recovery. Let's deep dive a bit in the cluster itself. As I said before, we use multi-cluster gateway. Imagine region 1 is in the US, region 2 is in Europe. This gateway can easily forward the request on whatever cluster you want, whatever cluster is needed, and this is also good for fault tolerance. So imagine having everything on a single region for whatever reason, customer request or what you name it. You can switch easily with one click to the second region, or without even clicking, you can have some automation, some workers that are switching from region A to region B, or having both of them. What you have to think about is always the cross-region, cross-continent traffic, that this can be pricey and also can add on latency. On the far right side, we have observability stack. What I said is mostly composed of Datadog, PagerDuty, and some other tools that are helping identifying also proactively if some incident is occurring. For one example is funding keys. So if a key is running out of funds, we have predictive alerts, so we can know it way in advance. Of course, we have automated workers in place, so keys are getting out of funds, they can be self-rebalanced. Also important, the workload and cost optimization. All of this can be costly, so you always need to take an eye on cost, and it's impossible if you have 100 chains. That's why we leverage on tools like Cast AI that are basically giving are self-rebalancing the cluster in a controlled manner, and of course give you a good overview of costs. What we learned in doing all of this? We learned that we always have to test on dev and testnet before major releases. So before you go to mainnet, if you have your own rollup, never patch it directly. Of course, yeah, this is the ABC, but also on a blockchain is the same. So always have another chain. It can cost a bit more, but you will be paid back after that. Horizontal scaling. So every chain is an ecosystem. You may have a chain that has 1,000 TPS, other 100 or whatever. So you have to be, your system has to scale, has to breathe on its own. So we use multi-zone persistent volumes. So the choice would be multi-zone or single zone. Of course, it's a bit more costly, but multi-zone persistent volume allow you to easily switch in case of disaster, or just because you want to go to the next region in no time. So you don't need to wait for a snapshot to be completed, restored, it's already there, you can attach to the next zone. Sizing your VPC accordingly. So you never know what's the size, how many chains, how many workloads you deploy, so make sure you think twice before this, otherwise you may need to eventually recreate your cluster. So think about your IP CIDR and all the limits around that. Observing GCP quotas. So this is another thing you need to pay attention. There are automation there, even on the Google UI, you can set your quota alerts, because you may be not allowed to spun up more than X CPUs on a given region, and if you have automation, you never know what's going to happen. So make sure you monitor it and you are informed beforehand. Testing your deployments in all phases with real traffic. Whenever you do auto-scaling tests, as soon as you go production, it's never real. So really make sure you are testing with real traffic, so you can really test the HPA or any other mechanism you have to go horizontal or vertical, depending on the case, especially if you are horizontally scaling with from a snapshot, because you can have 1 minute, 2 minutes, or a few minutes in a snapshot recovery, and this is critical. So if you are in a spike, you don't want to wait, so you may need to pre-warm your instances. Very last on the scaling is the Terraform state. Why it is on the scaling? Because in a rush, you want to separate each chain in its own state, and you don't want to mess up. Of course, you will never touch it manually, but segregation. Cost optimization, very last year, always tagging your resources for better visibility, having 100 customers will be very hard at some point to understand who is the spender. So you can easily tag your resources and you will get a nice report end of the month. Minimizing cross-AZ traffic. We saw before 3 zones. If you have your pods across 3 zones, you will pay the cross-AZ. So make sure that probably better to cluster services that are really verbose between each other in the same zone, of course with a disaster recovery plan or a fault-tolerant plan. Autopilot versus standard. So we learned that autopilot cluster is a great product, but doesn't scale with this type of chains, because what you want is stability, and you don't want pods to be reshuffled here and there, so you want to keep control. That's why I talked about some components like Cast AI. Instead, we use standard clusters. So we have full control. Eventually, we have some add-ons to reshuffle our nodes. And because we don't use autopilot, we leverage on different node pools and machine types. So node labels, you name it. And we have many node pools with specific machine types to just fulfill the requirement. That's all. Thank you.